Circular motion, exercise question 21 from HC Verma. Here is the top view of a horizontal ruler fixed at one end. A block of mass m sits on the ruler at a distance L from the pivot. When the ruler rotates, the block moves in a circle. The centripetal acceleration omega squared L points inward toward the pivot. Friction is the only horizontal force available to provide this centripetal force. In part B, when the ruler accelerates angularly, there is also a tangential acceleration alpha L, perpendicular to the centripetal one. The block slips when the net force exceeds friction. The question asks, a block of mass m is kept on a horizontal ruler. The friction coefficient between the ruler and the block is mu. The ruler is fixed at one end, and the block is at a distance L from the fixed end. The ruler is rotated about the fixed end in the horizontal plane. Part A, what is the maximum angular speed for which the block does not slip? Part B, if the angular speed is uniformly increased from 0 at angular acceleration alpha, at what angular speed will the block slip? The key concepts here. For circular motion, the centripetal force equals m omega squared L directed toward the pivot. On a horizontal surface, friction is the only horizontal force available to provide this centripetal force. Its maximum value is mu mg. Now, when the ruler also has angular acceleration alpha, the block experiences two perpendicular accelerations, centripetal acceleration omega squared L and tangential acceleration alpha L. The net acceleration is the square root of their squares added together. Part A, for uniform circular motion, the centripetal force equals friction. So m omega squared L equals mu mg, cancelling m from both sides, omega squared L equals mu g. Therefore, omega squared equals mu g over L, taking the square root, omega max equals the square root of mu g over L. Part B, now the ruler has angular acceleration alpha. The block has centripetal acceleration omega squared L and tangential acceleration alpha L. These are perpendicular. So the net acceleration is L times the square root of omega to the fourth plus alpha squared. The block slips when mu mg equals m times L times the square root of omega to the fourth plus alpha squared. Cancelling m and squaring both sides, we get mu squared g squared equals L squared times omega to the fourth plus alpha squared. Rearranging, omega to the fourth equals mu squared g squared over L squared minus alpha squared. Taking the fourth root, omega equals mu squared g squared over L squared minus alpha squared, all raised to the power 1/4. The answers. Part A, the maximum angular speed is omega max equals the square root of mu g over L. Part B, the block slips at omega equals mu squared g squared over L squared minus alpha squared, all raised to the power 1/4. Exam tips. First, for uniform circular motion with no angular acceleration, only centripetal acceleration exists. Simply equate friction to m omega squared r. Second, when there is angular acceleration, the centripetal and tangential accelerations are always perpendicular. You must use vector addition, not simple addition. Third, in part B, the result requires mu squared g squared over L squared to be greater than alpha squared. Otherwise the tangential acceleration alone exceeds friction and the block slips immediately at the start. Like and subscribe for more circular motion solutions at MAGPIEHUB.